Hi, welcome to Unit 2, Quiz Practice Select Solutions. This is question 8. In question 8, you're given KSP values and you're asked, based on the KSP above, which of the following will have the highest POH? All right, so we need to focus on what we're trying to find. We're trying to find the one with the highest POH. And what do we know about POH in terms of the information given here? You're given a bunch of metal hydroxide. So how does a metal hydroxide relate to POH? Highest POH means the lowest concentration of OH. It sort of works like the pH scale, whereas in the pH scale, the lower the pH scale, the more H plus. On the reverse side, the higher the pH scale, the less H plus. For POH, it's similar. The lower the POH, the more OH, and the higher the POH, the less OH. So basically they kind of go in opposite directions. So if you look at what's after the P, whether there's H or OH, the higher it is, the less of that you have. So since we're looking at the highest pH, we're looking at the lowest concentration of OH. Okay, so, well, in order to find the lowest concentration of OH, I need to look at their KSP values. And something to know about KSP, the higher the KSP, the more ions that you'll have. In this case, the ions, for example, would be silver and hydroxide. So the more hydroxides you would have, like the more it ionizes. So I'm looking for the one with the lowest KSP. And if there are two that are really close together or kind of close, like a couple orders of magnitudes away, then for those I would probably calculate the OH concentration using KSP. But in this case here, the one with the lowest KSP is at the order of 10 to the negative 33. The only one that's the next lowest one would be 10 to the negative 11. These are really far apart. So because they're so far apart, like I can just eliminate all of these and there's no need to actually solve anything. I'm just looking at the one with the lowest one, since because this is so far apart from the next lowest, I know that this must be my answer. No need to calculate. So the aluminum hydroxide would have the least amount of OH minus, and because the lowest KSP, there's no other KSP close. All right. What if we're in a situation where we were asked, well, what is the highest? Which one would have the highest pH? And this is like making it our own. So instead of the highest pH, we're going to be asked for the one with the lowest pH. So we basically just changed it. We just flipped it. The question. All right. So if we're looking for the one with the lowest pH, then my thinking is a little different. The lower the pH, that means the higher the OH. Remember, they work opposite. So I'm looking for the one with the highest concentration of OH, and that means, again, it's opposite. I'll be looking for the one with the highest KSP. So I'm looking through, and the top two have the highest KSP. And so I can eliminate these bottom two. And since these top two are kind of off, they're a couple of magnitudes away, like, I'll just test it just to be sure. They're not that close, but they're close enough for me to want to show you that you can test to be sure. So how do we test it? What we're going to do is we're going to see which one of these has the highest. Is it the silver or the calcium hydroxide? And for that, we're going to use molar solubility. So let's do it for silver hydroxide first. First thing I do is I write down the ionization of silver hydroxide. So that's when I dissolve it in water and it breaks apart into its ions. The next thing is I'm going to set up the KSP equation. This just helps keep me grounded. Remember, KSP is an equilibrium constant, and so that will be the concentration of products over reactants. However, we don't put the reactants in here because this is an ionic compound. And when you're dissolving ionic compounds, because it's an ionic because there's a metal and non-metal, when you're dissolving ionic compounds or salts, the reactants are in solid form, because you're picturing like you take table salt, it's a solid, then you put it in water to make it aqueous. So for those, it's solid, it's a solid. So as a result, it's not a part of the equilibrium expression. So on the equilibrium side, we have Ag plus and OH minus, and then they can go plop plop into our concentration. There's no coefficient in front of silver or hydroxide. Well, there's an invisible one, and those will be the powers that are here. So there's invisible ones there. All right, next thing we do is we say that, well, the concentration of Ag is going to be X. That's because the coefficient here is 1, so it's just going to be 1X. Like if you had 1 mole of this, you would get 1 mole of this. So this will be X and X. And then concentration of OH minus will also be X because, again, the coefficient here is 1, so it's just X. If the coefficient here was 3 or 2 or whatever, it will be 2X or 3X, but since it's just 1, it's just X. Now we're going to go ahead and plug the X in for our concentrations, and so we get the KSP is going to equal to X squared. So we just take X and plug them in, and that equals to X squared. And now since we know the KSP of AgOH, or silver hydroxide, is 1.9 times 10 to the minus 8, we substitute that in for our KSP. So 1.9 times 10 to the minus 8 is equal to X squared. Take a moment if you're lost now to try to figure out where we're at and how we got this. All right, good. Okay, so now what we're going to do is we're going to solve for X, because if we can solve for X, we can get our concentration of OH minus. Here, concentration of OH minus is equal to X, so once we have X, we have the concentration of OH minus. All right, so X equals, to solve, we would take the square root of both sides. That means that X is equal to square root of 1.9 times 10 to the minus 8, and that means the concentration of X is 0.00014 molar. So basically 1.4 times 10 to the minus 4 molar. We're going to do the same thing for calcium hydroxide. We just did it for silver hydroxide. Now we're going to do it for calcium hydroxide. So in this case, we write down this is our ionization reaction. It breaks apart into 2 hydroxides. Remember that this subscript becomes a coefficient because we're getting, when it breaks apart, we get 2 of these hydroxides. Now that we have that, next what we're going to do is write our KSP expression. So here in this case, KSP is equal to concentration of calcium times concentration of OH minus squared. The squared comes from the coefficient in front of hydroxide. Then we identify our concentrations in terms of X. So calcium is going to be X because the coefficient here is 1. So if you had 1 mole of this, you would get 1 mole of this. On the other hand, what should the concentration of OH minus be? If you have 1 mole of that, you would have 2 moles of that. So what should the concentration be in terms of X? Great, it should be 2X. Basically, it's the number in front and then the coefficient in front of it and then an X. Okay, once we have that, we can go ahead and plug that into our KSP expression. So concentration of calcium is X, so I plug that in. Concentration of hydroxide is 2X, so I plug that in. And when you do the math, you square the 2X, that gives you 4X squared, and multiply that by X, it gives you 4X cubed. So that's what our KSP is equal to in terms of X. We know from the table that KSP has the value of 7.9 times 10 to the minus 6, and we can go ahead and plug that in so we can solve for our X. Okay, so now that we have that plugged in, to solve for X, X is going to equal to, we divide 4 by both sides first and then take the cube root. So 7.9 times 10 to the minus 6 divided by 4, and then the cube root of that quotient. Once we do the math, we get that X is equal to 0.0125 molar. However, going back up here, we see that since we're trying to find concentration of OH minus, concentration of OH minus is not equal to X, but 2X. So to solve for it, what we need to do is we need to take the concentration of OH minus and double it. And that gives us 0.025 molar as the concentration of OH minus in the calcium hydroxide. Okay, so if we look at the values here, if we just line it up, concentration of OH minus in silver hydroxide is 1.4 times 10 to the minus 4, or 0.00014 molar. I may have put too many zeros in, but this value here. And for calcium hydroxide, it's 0.025 molar. And we can clearly see that this one, the calcium hydroxide, gives more a higher concentration of OH minus, and so it will have the lowest POH. All right, so remember, this is not question 8, but it's a modified version of question 8. All right, anyway, I hope you all found this video helpful. That is it for the selected solutions. Have a quality day.